For number 1, you're asking for the limit as x approaches 3 of a constant. So remember that whenever we have a constant, the answer will be just that constant. For number 2, we are looking as x approaches infinity, actually negative infinity. So I know the behavior of this graph looks like this. And as I'm going toward negative infinity, which should be in this direction, do you see that the graph goes toward y equals, or goes closer and closer to the x-axis, which means that value would be 0. All right, now for number 5, if I plug in 5 into the numerator, I'm going to get 0. And if I plug in 5 into the denominator, I'm also going to get 0. So that's an indeterminate. Now normally when we have an indeterminate, we would try to factor and cancel, but we can't do that here because I can't factor this. So what I'm going to start by doing is I'm going to start by plugging in numbers bigger than 5. So like I'm going to put a 6 here and here, then a 7 here and here, then an 8 here and here. And then I'm going to try numbers smaller than 5, like 4, 3, 2, and you're going to see that we end up having a pattern. So if I put 6 here, do you see that I get 1? And if I put 6 here, I also get 1. Okay, so I'm going to stick that up here. So when I have x equals 6, I end up getting y equals 1. Now, what happens when I plug in 7? So if I plug in 7 here, I get 2. And when I plug in 7 here, I also get 2. And 2 over 2 is 1. Now let's try plugging in x equals 8. Hopefully you're starting to see something. So when I plug in x equals 8, I'm going to get 3 over 3, which is 1. Okay, so then basically what's happening here is if I were drawing this graph, and here's 5, now at 5, let me state this differently. So I know that anything to the right of 5 will be at y equals 1, and at 5 there's no value. So it would look like that. Now I want to see what happens to the left of 5, so we can do this mentally. If I put a 4 here, I get negative 1, but in absolute value that becomes a positive 1. And over here, if I plug in a 4, I get negative 1. So I have 1 over negative 1, which is negative 1. Okay, so over here, my guess, and I'm just guessing right now, is that I may have a horizontal line going to the left. Let's see what happens when I plug in when I plug in 3. Well, 3 minus 5 is negative 2 in absolute value. That's positive 2. So I have a positive 2 here. And then when I plug in 3 here, I have a negative 2. So I have a positive 2 over a negative 2, which is negative 1 again. Trust me, if you keep plugging in numbers less than 5, you're going to end up getting negative 1. So if I want to sketch that picture, that's what that would look like. Okay? All right, so now let's look at what happens. This is asking what is the limit as x approaches 5. Well, that means I have to come from the left and I have to come from the right. And these values don't match up. So for number 5, the answer is D and E. D and E. Okay, now those were for the first column. Now I'm going to do the second column. Okay, so 5 over x. I know that that roughly looks like this. So as we go toward infinity, my answer would be 0. Because as I go toward infinity in this graph, the graph gets lower and lower and closer to 0. All right, next one, number 4. So normally I would just try to plug the number in first, right? Well, when I plug in the number 8 in the numerator, I get 0. And when I plug in 8 into the denominator, I get 16. Now that is not an indeterminate, that's totally fine. So we just reduce that, and that would be our answer. Okay, let's look at 6. 6 is the limit as x approaches infinity. So when we have infinity and we have something like this, Remember, we do n behavior, so we take the highest power in the numerator and the highest power in the denominator, and let's try to reduce that. And that ends up being -6. There's our answer. 7, I'm going to start by plugging in 2. So when I plug in 2 to the numerator, I get 4 plus 10 plus 6 over 4 plus 2, right? So that would be 20 over 6, which reduces to 10/3. All right, let's look at 8. That says x approaches infinity. So I'm going to take n behavior, highest power in the top and the bottom. That ends up being 15 over 10 because the x squareds cancel out. And let's just reduce that. And we have 3/2. Okay, number 1. If I plug in 1 into the numerator and the denominator, I get 0 over 0. So if I have an indeterminate, I want to take this expression and I want to factor that. So that's going to be x minus 2 and x minus 1. And in the denominator, x plus 1 and x minus 1. And then remember, the point of this is so that we can cancel factors, and then we can just reevaluate. Let me just kind of box this off in red. So then I'm going to reevaluate this as x approaches 1. Okay, so again, I'm going to just plug in 1 now into what I just boxed off in red. And when I do that, I am going to get a -1 in the numerator and 2 in the denominator. And there's your answer. Okay, now number 10, pi over 3, you should remember, is 60 degrees. So really what I'm going to do is I'm going to take the sine of 60 degrees, and that squared means to square that value. We don't square 60, we square the value of sine of 60. Well, the sine of 60 is radical 3 over 2. Make sure you memorize that stuff, guys. And I'm going to square that value, which is 3 over 4. Okay, 11. Pi over 6 is 30 degrees. Now, secant is the reciprocal trig function for cosine. So I'm going to start, just bear with me a second, I'm going to start by finding the cosine of 30 degrees. And I know the cosine of 30 degrees is radical 3 over 2. Now that's not what they asked for. They want the secant. So I know secant of 30 degrees, that's a reciprocal trig function. So I'm just going to take that value and I'm going to take its reciprocal. Now I can't leave it like that. Hopefully you remember that when you have a radical in the denominator, you need to rationalize that. So we're going to multiply the numerator and the denominator by a radical 3, and our final answer will be that limit will end up being 2 radical 3 over 3. Okay, number 12, pi over 6, that's 30 degrees. So I'm going to find the cosine, the cosine of 30 degrees, and I'm going to multiply that by the tangent of 30 degrees. Oh my goodness, that doesn't look like tangent. I'm so sorry, that's so ugly. So the cosine of 30 degrees I know is radical 3 over 2, and the tangent of 30 is radical 3 over 3. So I'm going to simplify that, and that's just going to be 3 over 6, which reduces to 1/2. Okay, last one on this page. I'm plugging in 0. So I'm doing e to the, well, 4x squared would be 0 plus 0, which is just e to the 0. And you should remember anything to the 0 power is 1. All right, so I'm going to start by taking the equation of that line and getting the y by itself. So that's going to be -2y equals -3x plus 14. And then I'm going to divide out that -2. Okay, so I have y equals 3/2 x minus 7. All right, now it says to write an equation of a line that's parallel to this one. So I know parallel lines have the same slope. Now it does say in point slope form. So y minus y1 equals, I know that the slope is 3/2 because parallel lines have the same slope, and then x minus x1. Okay, and then they gave you the point 2, -5, so that's going to be y minus -5, which is really plus 5, equals 3/2, and then x minus 2. All right, 15, we have to graph the piecewise function. Well, if we look at the first part, I have -2x minus 4. But we are only looking at the part of that graph that's less than -2. So I know that -2x minus 4 starts down at 1, 2, 3, 4. And then I'm going to go up 2 to the left 1. Now, I'm at -1. I need to get to -2. So I'm going to go up 2 more and to the left 1. So my first point is going to be at -2, 0 right there. All right. Now, it does say less than -2. So that means I'm going to have an open circle there. Then I'm going to keep going up 2 over 1, up 2 over 1, and maybe, whoops, one more, up 2 over 1. So there is y equals -2x minus 4 when x is less than -2. Okay, now the next part is x squared minus 2. Now x squared minus 2 is a parabola that shifted down 2 units, and it is between -2 and 1. So this is the vertex. Oops. That's the vertex of my parabola. Sorry, that looks like 2 points, but it's supposed to be one big one at 0, -2. Now remember the 1, 4, 9 method. So I'm going to go from this vertex. I go up 1, to the left 1, and to the right 1, and put a point. So let me do that. I'm going to have one right there, and I'm going to have one right there. Okay? Now, I just want to take a look here at my domain. My domain says stop when x is 1. And this is x is 1, so that's going to be the last point on that part of the parabola. However, over here it says to go to -2. And right now I'm at -1. So I need to plot another point there. So I'm going to go from here. Remember 1, 4, 9 says we went up 1, left, right 1. Now we're going to go up 4. 1, 2, 3, 4, and over 2. 1, 2. So I'm plotting the point -2, 2. Okay. So -2, 2 should be this point right there. Now that's a solid circle because there's an equal to. All right, let me point that out. Equal to. Not an equal to. So open circle at x equals 1. So that means I'm going to have an open circle right here. And my picture is going to look like that. All right, last part is y equals 2 when x is greater than or equal to 1. So y equals 2 when x is greater than or equal to 1 will be that line right there. Okay, because this is signifying that we have a horizontal line, and this is saying start it at 1 and go to the right. So I started at 1 and I went to the right. I'm going to plug in 3 into the top part of this piecewise function, which would give me the square root of 4, which is 2. And I'm also going to plug it into the bottom part of the piecewise function, which would also give me 2. So then what I've shown right here is the limit coming from the left is equal to the limit coming from the right. Okay? So we know that the limit exists. That's step 1. The next part is we have f of 3. This is where x is equal to 3. So f of 3 is also equal to 2. So ultimately, this is continuous. And the reason would be f of 3 is equal to the limit of the function as x approaches 3. All right, let's look at 17. We're going to do the same exact thing. So I'm going to plug in 1 this time. And when I plug in 1, I get 1 here. And when I plug in 1, I get 1 here. So this seems very similar to number 16, right? So this is the limit coming from the left. This is the limit coming from the right. And they equal the same thing. So I know the limit exists. This is f of 1 because that's where x is equal to 1. And it's also 1. So we can pretty much mimic exactly what we have in number 16, just change the numbers. So we have, this is continuous because f of 1 is equal to the limit of the function as x approaches 1. All right, let's look at the next one. I'm going to plug in 2. When I plug in 2 here, I get -4. When I plug in 2 here, I get -3. So we got a problem there. So this is not continuous because the limit of the function as x approaches 2 from the negative direction does not equal the limit of the function as x approaches 2 from the positive direction. Now we're going to be looking for a in this case and assuming continuity. So I'm going to plug in 2 here, I'm going to get 8, plug in 2 here, I'm going to get 4a. So to assume continuity would mean that the top part of the piecewise function when we plug in 2 and the bottom part should be equal to each other. So we have a equals 2. Let's do the same thing over here. So I'm going to plug in 3 in the top part of that piecewise function, I get 8. And when I plug it into the bottom part, I get 6a. And again, they're telling me it's continuous. So I'm just going to go ahead and set them equal to each other. So I have a equals 4/3. Alrighty, so we have to sketch a graph. I'm going to reduce this. So this should be 3 over 4x. So I know essentially the behavior of that graph is like this and like this. So this is an odd function because it's symmetric with respect to the origin. Remember, this with respect to the origin means if I were to rotate this graph around this point, if you had this on a piece of paper, turn your paper upside down, it's going to look exactly the same. And if it looks the same upside down as it did right side up, then we know that that's an odd function. All right, so let's look at part B. Now part B is a parabola, and it's shifted down 7. Now that 5 just means that it's going to be compressed or skinnier, 5 times as skinny, so to speak. But that does not really affect our graph all that much in terms of what we need to know for this particular question. All right, we're going to pretend that is a really bad graph. We don't have to pretend that, but that's -7. So this function is even because even means it's symmetric with respect to the y-axis. Righty, let's look at the next one. Write an equation of a line that passes through those 2 points in point-slope form. Well, first I need to find that slope. So I'm going to do y2 minus y1 over x2 minus x1. So that's going to give me 9 over -14. So there's my slope. So y minus y1 equals m, which is -9 over 14, x minus x1. Okay, guys, at this point it does not matter which point you put in. You can put in this first point right here or this second point right here, whichever one you prefer. I'm just going to go with the first to make life easy because it came first. So I'm going to have y minus 8 equals -9 over 14, and then x plus 5, because it's x minus a -5. Now you could have plugged in the other point, and that would be perfectly acceptable as well. Okay, a little bit of review here. This one is asking what angle has a cosine that's negative radical 2 over 2. Well, I'm going to ignore the negative for a minute. And I know the cosine of 45 is radical 2 over 2. So I know that 45 degrees is my reference angle. Now that negative comes into play because if you remember, all students take calculus, and we're looking for where cosine is negative. So that would be in the second quadrant and the third quadrant. So my values for x are going to be 45 degrees in the second quadrant, which is 135 degrees. And then in the third quadrant, that would be 225 degrees. Okay? In the second quadrant, you do 180 minus 45. And then in the third quadrant, you do 180 plus 45. Now, if you be very careful here, because this says radian form. These are not in radian form. So last thing that we need to do is we need to change those to radians. So for this one, we do 135, and remember we multiply by pi over 180. And then you simplify that, okay? So this is 3 pi over 4. So there's one answer. And lastly, we're going to do the same thing with this one. So that's 225 pi over 180. Simplify that one, and that's going to be 5 pi over 4. Okay, next one, 24, same deal. So I know radical 3 over 2, that's going to be a 60-degree angle. And I'm looking for where sine is negative. So sine is negative in the third and the fourth quadrant. So I know 60 degrees in the third quadrant is 180 plus 60, which is 240. And in the fourth quadrant, it's 360 minus 60, which is 300. And then all you need to do is multiply these guys by pi over 180. And then you're going to reduce your answer. And you will get, let's see, this one is 4 pi over 3. And this one is 5 pi over 3. Okay, last one on this page, 25. Radical 3 over 3. Well, I know that's a 30-degree angle, so I know my reference angle is 30 degrees. This value is positive, so we're looking for where tangent is positive, and tangent's positive in the first and the third quadrant. Well, 30 degrees, by the way, is in the first quadrant, so that's our first answer. I'm going to squeeze this in here. Sorry, angle X. The other possibility is in the third quadrant, so we do 180 plus 30, which is 210. Now we just need to multiply this by pi over 180, and this one by pi over 180. And let's see what we get. So we're going to have pi over 6, and here we are going to have 7 pi over 6. Okay, last page. So you can see that I just boxed off the given information and we just have to plug the numbers in. So this should be pretty easy. So in part A, you're just going to do 30 divided by negative 4, and we're just going to simplify that, and that's negative 15 halves. B, we are going to do the cube root of 8, right, which is 2, minus f of x, which is negative 4. And when we simplify that, that's 6. C, we are going to do 1/10 times g of x, which is 30. And then we're going to multiply that times h of x, which is 8. Well, 1/10 of 30 is 3. Oops, 3 times 8. So your final answer should be 24. Okay, last one, we have to write a piecewise function. So piecewise function. We've got 3 parts of this graph. Okay, so the first part on the far left, I'm going to work my way left to right. I am looking at this little segment right here, and it goes from -5 to -2. It's a horizontal line, so that's just y equals 0 because it's on the x-axis. So we have 0. And again, that graph is going from -5. -5 is less than or equal to x is less than or equal to -2. All right, let's look at the next part. This is a parabola, but it's flipped. So we know we should negate the x squared and also look at the fact that it's shifted up 4. Okay, so I'm going to say that again. It's flipped upside down, so that's going to be negative x squared. Okay, the negative represents the flipping. And then we are shifted up 4, so plus 4. All right, now let's look carefully at what we have here for the domain. It's starting at -2 and it's ending at 1 with a closed circle. Let's talk about this for a minute. We already included -2 in our domain here. We included it, I have an equal sign here. So for this part of the domain, we will not include -2 because if this part of the graph had a solid circle and then this part of the graph also had a solid circle at the same point, then you don't have a function because it wouldn't pass the vertical line test, okay, because you'd kind of have like two solid dots. So when you're doing your domain, let me write this first and then I'll further explain it. So you're going to have -2 is less than x is less than or equal to 1. Okay, so now let me explain again. I chose to put my equal to here, which means then I can't put it here. Let's say you chose to put an equal to here. That's totally fine. Then you can't put it here. It's one or the other. It doesn't matter which one you pick. Just pick one. So again, if I chose to put an equal to sign here underneath that less than, then I can't put the equal to sign here. One or the other, okay? All right, let's look at the equation of the last one. Well, this is a negative sloping line, and let's see, it looks like it's got a slope of -1. So I'm going to go up 1, left 1, up 1, left 1, and I see that its y-intercept is at 3. So that means the equation of that line is -x plus 3. And let's check out the domain for that one. So the domain starts at 2, but it doesn't include it, and it ends at 5, and it does include it. Okay, so that's going to be 2 is less than x is less than or equal to 5. And there's your answer.